Hi everyone, this is Mrs. J, and today we're going to be learning about the vertex form of quadratic functions, but first please pause the video and give this warm-up a try. Alright, go ahead and check your work here. So I started with coordinates for my parent function, which is just x squared, and then I noticed these four transformations, so I subtracted 1 from my x values where the horizontal translation left 1. Be careful, this should be a -1. And then for the reflection, stretch, and shift up, I multiplied my y values by -2, then added 8 to get these transformed coordinates. Alright, so today we're going to learn about one of the many forms of quadratic functions, which is called vertex form. So this form looks like this, a times x minus h quantity squared plus k. So it looks a lot like the forms we've been working with, and it also can be considered a transformational form because from this form you can see the transformations. Now it's called vertex form because we can look at this form and we can see what the vertex is. It's going to be hk. Now one thing to note is that the equation has this minus built in here. So this says negative h, but this says positive h, and that is on purpose. It's not a typo. What you see in the equation and the x value of the vertex should be opposites. Once you have your vertex, all you need to do is apply that vertical growth pattern that we talked about in the last lesson, which is that 1, 3, 5 growth pattern, which is adjusted for any stretch or shrink or reflection. So if you multiply 1, 3, 5 by your a value, it will give you the vertical growth pattern, which allows you to easily find more exact coordinates without having to make a t-chart. All right, let's give this first one a try together. So here we have 2 times x minus 1 squared minus 5. So again, I can look at this and I should know right off the bat that my vertex is positive 1, negative 5. So hk, and remember these should be opposites. From there, I need to identify my vertical growth pattern, which is going to be whatever my a value is, which in this case is 2, and then I'm going to multiply that to my 1, 3, 5 pattern, so it's actually going to grow at a pattern of 2, 6, 10. So let's graph what we have so far. So I'm going to start with the vertex at 1, negative 5. And then from my vertex, I go up 2, right 1. And then from that point, I go up 6, right 1. And then from that point, I go up 10, right 1. So again, it's the vertical distance to the next coordinate 1 unit to the right or left. Then we simply reflect it to the other side of our axis of symmetry, and we have our nice parabola. So that 1, 3, 5 trick is just a really quick and easy way to get additional exact coordinates so you don't have to make a t-chart. Our domain for these should always be all real numbers, and our range we can see is negative 5 inclusive to infinity. All right, let's try another one together. Let's start with the vertex. So our vertex is going to be the opposite of this. So negative 4, positive 3. And then I see that my a value in this case is 1/2, and there's the negative. So I'm going to actually multiply negative 1/2 to my 1, 3, 5 growth pattern. So I'm going to have to go down 1/2, down 3/2, and then down 5/2 to get exact coordinates. So again, I start at my vertex and I go down 1/2 unit, right 1, just estimate. And then from there I go down 3/2, right 1, and then I go down 7/2, right 1. And I can reflect that to the other side. There's my parabola. So that 1, 3, 5 trick works even if your a value is a fraction. You just may have to estimate where those coordinates are, which is fine. And then we have negative infinity to infinity for the domain. And remember, for range, you always go low to high, so it's going to be negative infinity to 3, and 3 is included. All right, go ahead and pause the video and give this one a try on your own. All right, go ahead and check your work. Make sure you have the opposite x value here. So our vertex should be at -7, -1. Because of that reflection, we're actually going to go down 1, down 3, and down 5 for our pattern. And then you can check your domain and range here. All right, I have another one for you to try on your own. I know it doesn't quite look like it's in vertex form, but it technically is. So pause the video and give it a shot. All right, go ahead and check your work here. So when it's written like this, you can imagine it written like this. It's just x minus 0 squared plus 2. So it's just saying your h value is 0. So again, this is still considered to be in transformation form. So our vertex is at 0, 2. Our growth pattern would be up 3, up 9, up 15, which goes off my graph. So I'll just plot those 5 points, and then you could see our domain and range here. All right, so now we're going to practice doing the opposite. Here I'm giving you a picture of a graph, and we're going to create the equation in vertex form. So when you're doing this, the first thing that I will always look for is our vertex, which we can see is -3, 6. And then in order for us to model this fully, we're going to need one additional point on our graph, and I'll show you why in a second. But you're going to need to look for a nice coordinate, so one where you can see that it's intersecting at integers. So there's lots of different coordinates you could pick. These would all be nice coordinates. You could pick one of these two. I'm just going to pick the coordinate -1, 4. So the reason why we need an extra point is because our vertex will tell us hk, but we need to figure out what our a value is. There's an infinite number of parabolas that go through this vertex. So by plugging in another point, we'll be able to find the a value that gives us this exact graph. So again, I can see that h is -3 and k is 6. That's from my vertex, -3, 6. So here's what I have so far. So x plus 3 squared plus 6. But now, again, to find a, I need to substitute an additional point. So I'm going to substitute the point -1, 4 temporarily. So I'm going to replace y with 4 and my x value with -1. And then that allows me to solve for a. So here we have 4 equals, this becomes +2 squared, which is 4. So 4a plus 6, and then I'm going to subtract 6 from both sides and divide by 4. So I can see that my a value is actually -1/2. So now I'm going to go back and substitute that, and I have y equals -1/2 times x plus 3 squared plus 6. So anytime you're modeling with this form, we need the vertex and an additional point to help us find the a value. All right, here's the last you try. Please pause the video and give it a shot. All right, go ahead and check your work. You can see that my vertex is at 1, -4, so I replaced h with 1 and k with -4. And then to solve for a, I chose this coordinate. Again, any other exact coordinate would work, but I substituted the coordinate 2, -1, which allowed me to solve for a, which is 3. So here's my final answer. All right, that is all for today's video. Thank you so much for watching.